My name's Ellis Patrick. So I'm a lecturer in the School of Mathematics and Statistics, and specifically I'm a statistician. I analyse data to find new ways to analyse data. And so that requires me to keep my finger on the pulse of not just the newest, spunkiest technologies, but also the new state-of-the-art statistical and machine learning algorithms. And so while I'm a statistician, people often refer to me as a bioinformatician as well. And so I spend my life analysing data from omics technologies. And so I don't know if you've heard much about omics, but that pretty much falls into the realm of anything kind of molecular. So genomics, transcriptomics, proteomics, epigenomics. And so we can use technologies to study these various different omics to really understand what's driving cells at a molecular level. Data is fundamental to my research. So as a statistician or a bioinformatician, I spend my life buried inside a computer, trawling through huge matrices of data to find interesting biological signals. So something that's got me really excited at the moment is a data set studying HIV. So in collaboration with Andrew Harmon and Tony Cunningham out at Westmead, we're using really high throughput imaging techniques to study cells and how they uptake HIV at the very early stages of transmission. So these new imaging technologies allow us to phenotype a variety of different cell types and cell subtypes, which means that we can see HIV interacting with lots of different cells. And so this data is not only exciting from a biology point of view, but also statistically and computationally. So the images that this data produces are 2 or 3 gigabytes per image, which creates these huge computational burdens to study these images. And then the vast array of cells that we track throughout these images just blows up in terms of all the spatial analysis. We can do nearest neighbor stuff. It's all very, very exciting. So my favorite data visualization tool is an incredibly simple one. And so that's the scatter plot. And I really don't think I can stress enough how important it is to use really simple data visualization tools to ask really simple questions and to understand where your data's actually come from, how you process it, how you manipulate it, how you read it in. All of these things are fundamental to being able to pull the data through an interesting pipeline and do some crazy cool stuff. Data science is fundamental to my research area. So more and more, like, science is a quantitative discipline, and with the technologies that we've got coming through, quantitation is blowing through the roof. So the ability for someone to be data literate is vital to being able to ask the scientific questions that we should be asking. So in terms of advice for data science students coming through the university, I can't stress enough the importance of science in the data science. I think it becomes really easy to become distracted by cool visualizations or fancy techniques, but unless you really understand the fundamental questions you're trying to ask, all of that is pretty much meaningless.